How's everybody doing today? All right, we'll go through it one step at a time. And what I'll do is I'll pause after what I have to say. If you have any questions about each item, okay, I'll answer any questions you might have, you know, so that you understand how each item works. All right? I mean, we can start with number one. Anybody doesn't know this is an electric heater? Okay, gets cold in this trailer for some reason. If the boilers go down, okay, this heater will come on. It'll keep all the pipes warm, keep everything from freezing. Okay, you also have heat trace on all the piping outside, just in case for the same reason. Okay, whatever reason the boiler goes down, okay, you're covered. Nothing's gonna freeze up here. Nothing's gonna freeze on the roof. Everything is under control. All right. We'll start off with this. This is your domestic hot water mixing station. All right. This controls the temperature of the hot water throughout the building. I don't know if you have what you have now, okay, but this is what they call a heat timer or ETV control. All right. This is the actual motor that modulates up and down according to the temperature this gets set at. Okay. We normally set them at 125. Okay. This meets city guidelines. Okay. It can be a little less if you're finding the water's good, or it could be a little bit more. All right, depending on what you want it at. All right. You have all your thermometers to tell you what it are. These are the sensors for it. Okay, that feed information to here. So this is your recirc line. You've got a thermometer here. It'll tell you what temperature the recirc line's coming back. Okay. Very important as far as, okay, you'll know if you have a problem mixing with faucets mixing somewhere in the building, cold water getting in. Okay.
What's the temperature coming back?
The temperature coming back is going to average anywhere between 100 and 120, what the mixing valve is set at. Okay. If it's not in between there and it's down at like 70 or 80 degrees, you've got a problem somewhere in the building. There's cold water getting into the hot water line. Okay. Usually a sign of either a faucet going bad that it's mixing, somebody hooked up a washing machine somewhere. Okay. We know the routine. All right. Everything has isolation valves. There's isolation valves on each side. Okay, you get a water leak in the pump, just shut both of these down. Okay, you have a bypass here. You open up the bypass, it won't be a circulator run line, but it'll be a gravity. Okay, so at least temporarily until somebody gets here to replace the pump, okay, you'll have hot water. All right, not as perfect. It may take 2 minutes or 3 minutes if they open the faucet. Okay, but it's not going to take 20 minutes. All right, so that takes care of that here. This here is your cold water feed into the trailer. All right. Any water leak that's disastrous that you feel you can't control, there's your magic valve. Okay, you shut this valve, shuts down every bit of water in this trailer, and you don't have to worry about anything. All right. This here, okay, is your feed valve for the boilers. Okay. I'm just letting you know what it is before I show you this, because you're seeing it and you think it's got nothing to do with this. This controls everything from here over. Okay? This is the ETV. Now it's telling you the water is 84 degrees. The target is 120 degrees right now. Okay? So it's telling me the valve's all the way up. Okay? These two black lines tell you whether the valve is up, all hot water, or down, more cold water. Okay? It gives you the instant readout of the temperature. Like you said, we're not showing hot water right now because you're still on the building hot water.
Yes.
Okay, until this is activated, we're sure everything's running correctly, and then we'll activate that. Okay? This is your RPZ for the feed valve. You got a water meter here. Okay? If there's a leak somewhere, you'll know because this water meter, okay, is going to send you a signal through the U.S. Energy panel, okay, that you've got water loss somewhere. This is where you got the water loss. That means there's water loss in the heating system somewhere. You'll see, you open this up, okay, you'll see it spinning. Okay? Otherwise you'll get a reading on the computer, whoever's watching the computer, okay? You'll get a reading that you're using excessive water. All right? This feeds the water to the boilers, should maintain 12 pounds of pressure at all times. Okay, so that you know there's pressure in the system and everything will run good. Again, it's valved off for any reason. This valve here is on a gauge. Okay? Any pressure gauge that has a valve, the valve should be in the off position. Should not be on. It's strictly if you want to walk up here and say, hey, how much pressure? You go like this, you open it up, it reads the pressure, and then you shut it off. Because otherwise, valves fail, they blow up, you got, you know, you got floods in here. You don't need that aggravation. So you make sure any pressure valve stays shut, okay? This is your, what they call thermal expansion tank for the domestic water, okay? As the water heats up, you got a check valve. It's got to have somewhere to go because it can't back up into the main. It goes into the tank, all right? As it cools down, it pushes the water back into the system. Okay, it takes the up and down of the pressure, okay, so that no relief valves leak, okay? It stays on all the time, all right? We'll move on down this way. These are your domestic hot water tanks, okay? These are going to supply hot water to the building. You have 218 gallons of storage here. Each tank is 109 gallons, okay? They both run independent of each other. This here is the aquastat, okay? You see I took the cover off on this one. This is how the temperature gets set on the tank. The temperature will be set at 135, okay? You have to be higher than you have it at the mixing valve, okay? So the stored water will be going out to the mixing valve at 135, but you'll only have 125 going to the building, all right? So if you have, you'll see there's a little green light on top here. The green light tells you that it's calling for hot water. There's also the light here that tells you, I want hot water, I want to make hot water, okay? So everything at that point, this pump is for tank number 1, okay? This is a backup, okay? They both work to control both tanks. There's a sequencer that if one pump fails, it'll automatically switch over to the other, all right, so you don't lose hot water. And they'll rotate every 96 hours. So you get equal run time on both pumps. You're not overheating your pumps or putting excessive wear on one pump and not the other, okay? All for the efficiency of it. These take the water from the heating system, okay, and run them through these heat exchangers. There's 2 heat exchangers, okay? So the water runs through one side of the heat exchanger to get the heat exchanger warm, all right? Now you have your brass pumps, okay, down bottom on each tank. They feed through the other side of the heat exchanger. They move the water from the tanks through the heat exchanger and mix it with the heated water from the heating system, and that's what heats up the tanks, okay? It makes the tanks warm, all right? And it keeps it warm. They will run, okay, after the coil is gone, okay? And if you just happen to be here, you say, oh, the pump didn't shut off. The pump will run for a minute and a half, okay, after it shuts down to purge the lines out and get rid of any excess heat in the lines and put it to the tank so that it's more efficient, okay? So those are your accents. You have valves on everything, okay? This side is your heat exchanger coming in, okay, from the heating system. So if the heat exchanger or something, the relief valve leaks, you can shut these valves, okay? The domestic side is right here. It's not going to have a shut-off valve on it. I'm not sure why, to be honest with you, okay? I'm a little flabbergasted at that, but there's no shut-off valve on the domestic side of it. So if the pump had to be changed, okay, the only way we can do it, it's not a big deal, okay? Instead of, probably because of space constraints, we'd have to shut the hot and cold water feeding the tanks.
Why would you just switch tanks?
Huh?
Turn one tank off?
Well, yeah, you can. That's what I'm saying with the valves for the heat exchanger. You'll get nothing to the other the other tank, okay?
Yeah.
But for you shut the domestic side, you're going to have to shut the valve up top over there, okay, which is your domestic hot water coming out. You can isolate each tank. There's a valve on this one. There's a valve on that one. There's a valve here for this tank, and there's a valve here for that tank.
Okay.
So you can isolate the tanks in any shape or form.
Yeah.
Okay, the domestic side and the heating side. All right? And looking at it now, I say there's no place to put a valve there because of the constraints there. All right?
Yeah, what I'm saying is you could use this tank, shut this
Yes.
one down if you want to replace
You can shut this down, run.
and then run the other system.
Exactly.
Okay.
Okay?
Yeah.
Again, everything's got shut-off valves. Okay? You see this Y strainer here. You say, what is this Y strainer for? Okay? For people that don't know what it's for. You hook a hose up to this, run it out onto the roof, okay? This should be flushed out at least once a month, okay, to make sure there's no sediment buildup in there, okay? That keeps any sediment from getting in the heat exchanger and clogging up the heat exchanger, okay? You don't want to lose a heat exchanger because of dirt. This is to protect it. You keep them flushed, you'll have no problem. Worst comes to worst, if you don't get any water out of it, you can shut the valves. They take a wrench here, you unscrew it, you can pull the strainer out and clean the strainer by hand. There is a drain on both tanks, okay? The amount of hot water you're going to go through here, I would say once a month you take flush down, clear off the bottom of the tank. 2 large VFD pumps, okay? These supply the heat to the building, all right? Redundancy, everything's redundancy as you see, okay, in the trailer. Okay, there's backup for everything. Same thing, one will run at a time, okay? They'll rotate every 96 hours, okay? And switch on and off. No need for you to run 2 at the same time. It's not gonna make the system any better or any worse, okay? It's just to run efficiently, all right?
Just a backup.
Huh?
Just a backup.
Just a backup. Again, there's valves on these, okay? I hate to walk into a trailer or anywhere and see the valves open. Okay, all pressure valves should be in the closed position. Okay, this one's closed. That one's closed. Okay. That one. Okay. These just tell you if the. I'll get that in a little bit. Okay. These gauges will tell you how the pump is running. It's not going to tell you what the pressure is in the system. It's going to tell you how the pump is running. There's always going to be a difference in pressure from one side of the pump to the other. That's called your head pressure. That way you'll know the pump is moving the water. If you have equal pressure on each side of the pump, you have no head pressure, there's something wrong with the impeller and the pump, you want to switch over to the other pump. Okay? Again, one here, one here.
What is that pressure? What is that pressure typically in the loop?
The inlet pressure will be whatever the system pressure is, and the outlet pressure will be about 10 to 15 pounds higher.
10 to 15, okay.
Okay? Because it's the differential of the moving of the water. All right? Valves to shut off the supplies to the building right here, these 2 red valves. Okay, that'll shut off any supply water going out to the building. All right? Down here is your regular expansion tank for the boilers. Same thing as the tanks, as the boilers heat up and the system heats up, it's got to have somewhere to go. That's where it goes. Okay, and as it cools down, it goes back to the tank. There's a valve on here, it's strictly for testing purposes. There's no need to flush that, no need to touch it at all. Okay? Huh?
What about this system?
This system here, okay, you'd have to shut this valve, okay, and shut this. This screws all the way in, okay? And once a year, this strain is in here,
Yeah.
okay, that should be pulled out and cleaned.
Slow it down.
Once a year.
Yeah. You can blow them down once a month, okay, but once a year you should really pull that strainer and make sure it's good.
Okay.
Okay, because that's, like the heat exchangers, that's going to prevent any baseboard and convectors in the building from getting clogged up with gunk.
Switch it over, turn off, and then switch over. Okay.
Yes, all right? And to do that, you don't even have to turn everything else off. You can leave everything running, just shut these valves, okay? And you can drop that out. It should always be in the auto on. The light for the auto on should be lit. I'll do it for a second here. Okay, you see it switches over?
All right, that one, yeah.
Okay, that's auto, okay? We'll go back to off because we don't want to have the noise in here right now,
Yeah.
for you to listen to the noise, okay? Again, expansion tank has a relief valve. That's telling you, okay, the boilers, I'd be surprised if that's relieving and the boiler relief valves aren't relieving, but it could be just a bad relief valve on the tank. They're required by code now. Okay, as you can see, you have 2 boilers here, all right? They run lead lag, okay? This is boiler number 2, or this is the slave boiler. This boiler will not run unless this boiler gives it a signal to run. This boiler decides according to temperature. It decides, it says, listen, I can't keep up with the load. It transfers over to this one, brings it up to whatever percentage it needs, all right, to bring the temperature up fast, all right? It'll also ramp down. It'll also, the main control panel in here will also say, you know what, I have too much runtime, you don't have as much runtime. I'm going to run you today, and I'm not going to run.
Okay.
It's got a brain of its own, and it decides what it's going to do and alternate it. No more worried about shutting the switch off or turning the switch on. It thinks ahead of us.
Go in the lead lag.
Okay, it goes in the lead lag, and they rotate and they go up and down according on the header temperature sensor there. That's what's telling the boilers what to do. Okay. This is actually what it looks like inside the cover. All right. This here is your high limit control. It's set for 210 degrees. If the boiler temperatures go up to 210 degrees, shuts them down. Will not come back on unless you push this reset button. Okay? There's no harm in pressing the reset button once. Okay? You walk over and you look at it, you say, okay, what's the temperature set at? Okay, here we go, here's the notch, it's set at 210 degrees. Nobody touched it, it's where it's supposed to be. 210 degrees is where it should be, never lower, because it's only a safety, okay, for high limit. Once you see it's at 200 degrees, you hit the reset button, let the boiler fire up again. If it comes up and shuts off again, now leave it off and call for help, okay? This is only telling you what it's set at. It's not telling you what the temperature of the boiler is. Temperature of the boiler is right here on this display screen.
Now, what about if that happens? Can I switch over to this one right away?
It'll switch over on its own. Automatically switch over to the other boiler. Okay, and run on the other boiler. Okay, so you'll have heat. You'll just know you have a problem with this boiler, and you're going to have to call for service to get this boiler serviced. Okay. The actual water temperature is displayed here. Okay, so you know what the temperature is at all times. Or, I don't know where the remote setup is. Okay, we'll get to that in a minute, but there's a remote setup that you can find out what everything's doing. All right? This is switch for the on-off. It's off right now. You see when it goes on, the light turns green. It tells you, hey, I'm ready to go.
Now, if we have a problem with that, should I hit that off switch or just leave it alone?
If it goes off on the manual reset, just leave it off on the manual reset.
Okay.
It's not gonna come on. You don't have to turn the switches off. Okay, it knows, and it locks it out completely, because this is totally independent of the control. The control can no longer function because that stops it from functioning. Okay. You should take the covers off once a year, okay? Make sure this filter's clean. All right, it's pulling air from the outside, okay? It's pulling air in through the back, okay? And this is where it's sucking all its air for combustion through that air cleaner, okay? That, again, when we're servicing it once a year, we'll take care of it, all right? But in the beginning, okay, you don't know what kind of debris you have in the air here, okay? You may have to be done twice a year, may have to be done 3 times a year. Okay, depending. You're on the water, okay? Gets windy, kicks up a lot of sand, you never know. Okay, so there's no harm in just looking at it to see what it looks like and make sure it's okay. The cover comes off very easily, okay? You just pull the handles, okay, and you get right in there. You put the cover back, okay? And you lock them down. Okay? It's not rocket science, it's easy. Everybody likes easy. All right? Or you're used to having gas before, you have gas pressure switches. These are non-resettable. Okay? You can't reset these. There's no sense taking the panel off to try. Okay? Because if it tells you low gas pressure, it's going to tell you low gas pressure on the display. And when it tells you low gas pressure, you're going to walk over here, okay, or low water, whatever. You know the boiler's not running. It's in fault, because it'll say fault, and it'll tell you exactly what the fault is.
Right.
All right? So you walk over here. If it's low water, you're going to hit this reset here, okay, because this is one lower cutoff that's built into the boiler. And when we go around back, I'll show you there's a second low water cutoff that can be reset from the back of the boiler. All right? But any faults will give you a fault, okay? Time, date, okay, and what it is. You can hit the clear button. It'll go through a recycle. It'll try to start up. If the fault has fixed itself for whatever reason, the boiler will light and it'll start up. If it hasn't, again, you got to call for service. The control panel is just you can scroll through using the arrows to see different settings or what flame settings are, but there's nothing else in there for you because everything's password protected, because you really don't know what you're looking at inside that panel. Okay, it'll let you do certain things for temperatures and resets, and it'll say okay, but once you reach that point, it's going to say no, I want a password. I'm not letting you do anything. All right? Okay. These are what I said. These are the fresh air intakes. This is where it pulls the fresh air from outside the trailer on the side. So always should make sure there's no bird made a nest or whatever outside. You'll see them outside. They're like a dry event.
Yeah.
Okay? You know, just do a once a week glance through. Make sure everything's clear. All right? You'll have no problems with these. Your natural gas shutoff valves are here and there on each boiler. You smell gas, you think there's anything, just shut it off right away. Don't even hesitate. You know, call us, let us come bubble check it or whatever we need to do. Okay, it's the one thing, you're in a confined space here. You don't want to have a gas leak in a confined space. You immediately, any hint of anything, you just shut it off. Better to be safe than sorry. All right? These valves here, okay, these are your return water for the system. Once you shut those down, that's it for the return. So if you want to isolate the whole building, the two supply valves over there by the pumps, and these two valves here, okay, you shut it down. The whole system's down. They're not getting any water in the building at all, to any of the radiators or any of the heat piping. That's your safety factor there. Okay? This is your secondary low water cutoff right here. I know it's a little difficult to see. All right? But there is two buttons on it. The button to the left is a test button. Just like that one there. The button to the left is a test button. To say you were wondering if it worked, you were curious, you could press and hold the test button, and it'll set it off on low water.
Okay.
Then you can hit the reset button. Okay?
Go back.
Once you hit the reset button, she's back in the cycle. And you'll know it's off on reset because there's a red light on top that'll be lit. It tells you it's off on low water and it's not going to come back on until it's reset. Okay? This here, okay, this is your condensate trap. Okay, for the drain water coming out of the bottom of the boiler. You got to check it and make sure it's clear that the water's coming through. All right? Easiest way to check it, okay, frequently, this is once a year, okay, no more than once a year, okay, because you're not going to build up that much, all right? But the easiest way to check that, as you can see, these lines all go into this gray line, okay? You walk along, and you follow the gray line, okay? See it dripping now? Okay? It's telling you that those drains are clear and they're working. You're always going to have water coming into this drain because that's what makes these boilers efficient, is they're condensing boilers. They suck every last bit of heat out that they can. All right? And that causes the gas to condense. Whatever's left, it condenses and it comes out here. Each container has its own circuit breaker panel. Okay? Everything electrical in this trailer can be isolated and take care of from here. Okay? You see the labels? It's telling you exactly which breakers do what. Okay, so you can shut off individual stuff. If you're nervous and you can't find it, like anything else, there's the main breaker. Shut it off. Go up for help, right?
We have a key.
Yeah, you have a key, right?
Yes.
We leave the key here taped inside, okay, because we don't lock them. If you want to lock it, that's up to you.
I don't wanna lock it,
Okay,
I'm
but
saying
we don't lock them because people have a bad habit of losing keys.
keys, yes.
So we just leave, we find it's better unlocked. It's an emergency thing, it's a safety thing to be able to get into right away. So I don't know why people lock them. I really don't. There shouldn't be a lock on that box. But that's how they manufacture them. This is your main control panel, okay, for the whole trailer. This tells you what everything's doing. Right now you can see there's a call for domestic water and there's a call for the BMS. This is the BMS, Building Management System, all right? It's telling you it's calling for both. The boilers should be running, the circulator pumps for the domestic should be running, and the heat should be running right now. I have them all off, that's why there's no other lights on, okay? We'll take this one for example. This is domestic hot water pump number 1. It tells you come in here, it's failed, something's wrong with the pump, all right? It's an overload, short circuit somewhere, all right? So this pump's not gonna run. And green is running, tells you it's running, all right? You can turn the pump off here, okay, to off. So isolate that pump so it only runs on the one set of pump,
Yeah.
all right? When this comes on, either one of these, okay, domestic hot water pump 1 or 2, domestic hot water pump 1 and 2 is both pumps for tank number 1 and both pumps for number 2.
Okay.
It controls, because both pumps have to run simultaneously. They can't run without each other, all right?
Yeah.
So you're isolating at that. You leave it in auto at all times. If for some reason you have a call for domestic water and the pumps aren't running and you don't know why, put them into hand.
Yeah.
You put it into hand, it comes on, there's a relay or something wrong inside the panel, it's got to be replaced, but you have hot water for now.
Yeah.
Okay? Same thing with the heat pumps. Okay? Same thing. Okay? They're off now, but you have hand auto. All right? Always in auto. You got a problem, you can't get it to run, put it in hand. All right? These should always stay in auto. Okay? These two. It says domestic hot water lead pump. If they want 1 to run all the time or 2 to run all the time, you want to let it do it automatically on its own so it cycles. Let it vary. Okay? The hot water pump control is remote. Remote means something's calling for hot water and it's going to run.
Okay.
If it fails, okay, you can go to local control and it'll run local. All right?
Yeah.
There's no reason you can't. If you come in and the alarm light will be on and this is singing,
Yeah.
okay, it's going to tell you high CO, the boiler failed, okay, any one of the pumps failed. You can hit silence,
So
okay.
You can figure it out.
It shuts the alarm off. Okay, you can try to go to hand, okay, to run the pumps. Okay, it's basically telling you the pump hasn't come on and you got to find out why.
Okay.
You can't find out why? We'll find out why.
Yes.
I mean, it's good for the first year, okay, you know, we're doing everything here, okay? So the best thing you can do is when you have a service call and the service guy is here, the best thing you can do is watch what he's doing. The only time the boilers will come on if there's no call for here, okay, is if there's domestic hot water. Any call for heat, all right, comes through this panel. The panel energizes circulators, okay, and the boilers. These boilers will not run at all unless one set of pumps is running. It's a built-in safety that there has to be flow through the boiler for the boiler to run. If there's no flow, the boilers will not run because they'll overheat instantaneously. They heat up that fast.
Okay.
Okay? So the pump, there has to be, and that's what you're seeing with the domestic call. Domestic call, you'll hear the pumps kick in. When the pumps come up to speed, it tells the panel, okay, we're ready, turns the boiler on. Okay? Same thing with the heat pump. Okay? You see the BMS call? The pump's going to start up. The boiler's not going to come on right away. This has to come up to speed, and then the boiler will come on.
Okay.
All right?
What
Everything's
else?
off of there. This panel is inside the trailer really for our information or your information if you're up here. Okay? Management of the building. Okay? I'm sure they're on computer.
Yeah, they're waiting for the data to come in, and then we do a separate formal training on the BMS.
Right, okay. You'll be able to sit at the computer, okay, you'll bring up the panel, and it'll tell you everything that's going on in this room. It tells you what the temperature is of the supply, the return, the hot water, the stack temperature, what the temperature is in the boiler room itself, okay, what the temperature is outside. That's what it's doing, it's monitoring. It's going to tell you the temperature in all the apartments. You have sensors in all the apartments. That's how it works, okay? It takes the outdoor temperature. It says, okay, like today, let's say today, okay? It's above 55 degrees. I don't need to run today for heat. It will not let the boiler run. Unless, by the new law, okay, several of the apartments, an average of, how many sensors here? 28?
The repeaters or the
sensors?
53.
53 sensors. So it's going to take an average of 10 sensors. And it's going to say, how are we doing? And even if it's 60 degrees out, if the apartment falls below 64 degrees, by New York City law now, it's going to turn the heat on. Even though it's saying that, oh, it's 55, it's going to override that 55 because the apartment's now too cold. Okay? So it's using two different sets of logic to turn it on and off. Okay, and you will see that on the computer screen. It's going to tell you, it's going to email whoever if there's a failure, the boiler goes down. Okay, it's not anymore, oh, I have no heat, and the super's got to run up to the top and say, oh, the boiler's not on. You should know that long before the people are cold, because you're going to get an alert. Okay, the water's too cold. Okay, something's going on. You got to go check out the boiler. Okay, that's the nicest part of that. It gives you everything ahead of time. Everything ahead of time. There's no waiting for answers or saying, you know, everything's ice cold. Why is it? You know it. All right. People aren't even going to be calling you. You're going to know before they call you. You're going to be saying, look at this building cooling down. I'm getting alerts from different apartments. All right. If they pull that, and it takes an average of 10 sensors, because it says, well, maybe this woman's got the stove on. Maybe this woman put an ice bag on it. Okay. It's not relying on just one sensor or two sensors and saying, oh, you know, this apartment's cold, I'm going to turn it on. It's taking an average. And what happens with that average, which is nice, okay, is if you find you are overheating the building, okay, you say to yourself, I can't believe these apartments are 62 degrees and all the rest is 70. You know what you're going to do? You're going to change the 10 sensors that determine it to different areas, and you're going to block those out. So you have that's how you have maximum control over your building. Okay? It works out perfect that way. All right? You have a break glass station outside the door on the wall. Cases of emergency, okay? You hear noises in here that you don't want to go in.
Shut it, break it.
Break the glass. Okay, the button will pop, everything will shut down. All right? If you're in here and if something happens and you're not sure, right against the back door there, okay, there's another emergency switch. Okay, because there has to be an emergency switch at every entrance. There's two ways of bypassing the system. Okay? There's the manual way. You walk over to that control and put it in bypass. Okay? And this panel will tell you at the computer somebody bypassed it. So nobody can bypass it without you knowing it. You'll say, why is this in bypass? And you can send somebody up to check it and say, well, somebody must have left it in bypass.
System.
You know what? My servicemen are human. Maybe they put it on bypass to test something and they forgot to put it back. Okay, you'll know they forgot to put it back, or you'll know you forgot to put it back because you're getting a signal that system's on bypass. You'll get an alert. At the end of the day, you'll get an alert. Somebody has a system on bypass. It doesn't say you have to do anything about it. It's just telling you so that you can take the appropriate action. Okay? But normally this stays in the control side.
By bypass, what is it doing to the system?
Bypassing means you could run for heat on a 90-degree day.
And that comes out on the computer too, that we can bypass it from the
That's right. You can bypass it right from the office. You could say, listen, I think I'm going to give them a little heat. You can click right on the screen and say bypass. You hit bypass.
Pretty good.
A minute later, you'll see that light flash, bypass boiler's on. You'll actually see the boilers come on, okay, and the lights will light up that the boilers are running and the pumps are running. Thank you for spending the time with us.
Thank you.
I hope you'll know what to do in the future.
I'm gonna call you.
You're gonna call us.
Yes, exactly.